In this video, we're asked to write a program that takes the radius of a sphere as an input. The radius is actually going to be a floating point number, so we have to remember to ask the input to be a floating number, and then it outputs the sphere's diameter, circumference, surface area, and volume. In the comment above, I actually included the formulas for the above that's asked for here for the sphere. So the diameter equals the radius times 2, circumference 2 pi r, surface area for pi r squared, and finally the volume, which is pi r cubed times 4 over 3. We'll go ahead and ask the user to input the radius of a sphere. We'll go ahead and enter it in this way. So we'll go ahead and initialize radius to be a float, and we're going to ask the user to input in the form of a message, which will be enter the radius of the sphere. Now notice that I'm not really asking for what kind of units they'll be in. It's not necessarily important at this time. Just know that it'll be in some form of a unit. So it could be unit squared, it could be unit cubed, and so on and so forth. The radius itself is ready to go to be asked here. And then we'll go ahead and follow the next steps, which is to actually compute each formula based off based off the radius that the user inputted. Before I do that, or before I forget, I'm going to go ahead and create a comment here to determine what these coding blocks are for. So here I am initializing radius, and I'll go ahead and quote that radius to be, let's say, initialize radius and to ask end user for input. So that takes care of that. So here, in the next code block, we'll go ahead and compute the sphere's diameter, circumference, surface area, and volume. We're going to start with the easiest one, which would be the diameter. So we're going to go ahead and initialize diameter here. And diameter is simply going to be whatever the radius is times 2. Very simple. The next step would be the circumference, which would be, and let's make sure I spelled that correctly because I don't want to screw that up later in the program. So circumference will be equal to 2 pi r. The easiest ones here would be to enter the 2 and then times the radius. We also want to enter pi, so we can do two things here. One, we can go ahead and enter 3.14 in terms of pi, or we can actually import a module that will give us a number for us. So it really depends on what you want to do and how specific or how accurate you want your numbers to be. So in this case, what I am going to do is I am actually going to import a module so that I can later use as in the form of math.py. And I'll show you exactly what I mean by that. In order to import any module, you'll have to find out what the module name is before you can even use it. In this case, my module will be math. So I'm going to import math. And what I'm doing here is basically taking a set of functions that belong to this module, and then I'll later use it in my program. The function that I'm specifically worried about is math.py, because math.py will give me a much more accurate number for pi. So here, again, the circumference is going to be equal to 2 pi r. So I'm actually going to enter math.pi as the number times the radius. Next, I am going to write the formula for the surface area, and this is just going to be 4 times pi r squared. So again, I'm going to use math.pi, and I'm going to use the radius and bring it to the second power, which is our r squared, and that takes care of the surface area formula. And finally, I have the volume. The volume can be interpreted in different ways in terms of how you want to interpret 4/3. So you can actually use 4/3 in this way. So the division will occur, and whatever answer they get from that division will be later applied to the formula. So I'll go ahead and multiply that by math.pi, and then this radius will be brought to the power of 3. So keep in mind that that's exactly what you're trying to do here. One thing that I like to do when I work with numbers, and I should have done this before, but it's not really a big deal because we'll get some sort of answer, but we want accuracy as well, is that I want to turn these into floats so that I can make sure that we're not getting any weird messed up answers when we're mixing integers with floats. So I'm just gonna add 0.0 to the end of each number. Let me do it here too. Okay, so once we have our formulas, we'll go ahead and output the results for the sphere's diameter. Excuse me, diameter, circumference, surface area, and volume. And depending on how you want to actually output this, so we can say something like diameter, and then we'll have diameter here. We can do print circumference, and we'll have circumference variable printed out. We'll have one for surface area, and then surface area will be called here. Then finally, we'll have one for volume. We'll go ahead and run that for volume as well. And that should be it. So let me go ahead and fix this and capitalize that to C. Let me spell this volume correctly. So that'll be U. Alright, let's see if it works. Now, we want to make sure that it works and it's running. If we run into any errors, we'll go ahead and fix those. But for the most part, let's try something rather simple. Let's try the radius being 2. And the radius gives us a different answers here. So let's make sure we are checking our math correctly. 2 times 2.0 for the diameter is going to be 4, so that's correct. We're going to run the circumference as 2 times 2, which is 4, and then 4 times 3.14, so roughly around 3 something. That sounds about right as well. 12 point, and then this large number. The large number is it's actually a result of math.pi, because math.pi has a huge number. Instead of the 3.1415 that we're normally used to, it's actually 3.14159 to 653 589 793. Obviously, that's a lot of digits, and that's why we have so many decimal digits after the decimal for each one, because wherever we use math.pi, that's where we're getting this big amount from. You can always round it to a specific number, a specific degree of digits, a precision, so to speak. But we're not going to worry about that right now. We're just going to worry about the math being correct for these values and outputting them as a result. We'll go ahead and try one more value just to make sure everything looks okay. We entered this radius as a float in the previous run. First run that we did with the number 2, that was actually an integer, so we're going to actually try something new. We're going to do 3.9, and it looks like it's still running just as fine. Again, you guys can do the math on here to see if it's correct. It actually is correct, but what you want to always make sure that you're looking for whenever you try to debug or run tests on your programs is that you try as many examples, as many inputs as you can to see if anything changes, any behaviors change. That'll make your program a lot less susceptible to errors, logic errors, and things like that. Let me know if this was helpful, and if you have any questions, you're always more than welcome to put a comment down below. I'll see you soon.